Part TP6. Okay, simple experiment, boleh buat video nanti. Okay, nampak belum teacher punya screen? Can you see my screen? Sorry, interruption. Biasalah dekat rumah anak-anak. Okay, can you see my screen? Yes? Tak nampak kan? Okay, kita nak semak. Okay, these are exercise that you have to do in your previous class. Only one student completed the exercise. Congratulations to Edison. Yang tak masuk lagi Edison. Where is Edison? What tag dia? Edison, where are you? Okay. So first of all, you have to do simple notes and then you have to answer practice from 8.3. Okay. So put in the answer correctly lah. Okay, chlorine. The first one, you paling senang sekali, you nak tahu nuclear number. Ya, satu baru masuk. Kita nak add tu. Okay, bila teacher present, teacher tak boleh, dia tak auto add. Edison dah masuk dah. Okay. Okay. So kita tengok. Yang paling mudah sekali you want to check the nuclear number. You see all the names, nama-nama this isotope, dia punya number dekat belakang ni, this is the nuclear number. If here 35, here also 35. Here 37, also here 37. Tak ada nak masuk ni. Anybody want to? Okay, vision. Okay. Okay, then. Okay. You tengok for question ni, dia tak bagi the number of protons. Okay. Tapi kita tahu bawah ni juga chlorine. Same name means that isotope have same number of protons. If here are 17, atas ni juga 17. Okay, the difference is at the number of neutrons. So how it get 18? 35 minus 17 will become 18. Okay, 17 plus 18 become 35. Hasil tambah 2 ini akan jadi ini. Okay, same nama, same element, same number of protons. But because it is isotope, nampak belakang ni beza, means the number of neutrons that is different. Okay, you complete lah sampai habis. Okay, boleh tengok jawapan Edison ni, very good. Okay, in medical field, sodium 24 is used to determine where the blood clots inside the body. Okay, correct. Cobalt 60 we use to kill cancer cells. Iodine 131 is used to track thyroid gland disease, penyakit. Untuk treat, untuk rawat thyroid gland disease. Siapa nak masuk? Sorry. Mana ni nama tak keluar? Okay, Jeremy. Okay, good morning. Yang baru masuk, good morning. Okay, next. In agriculture, phosphorus 32 to study the rate of absorption of fertilizer. Kita tambah sikit lah, absorption of fertilizer. Okay, in plants. Okay, for carbon 14, track history or we said as tracer studies. Carbon 14 in agriculture is used to trace how many carbon is inside the plants. Okay, so it is used as tracer studies. Okay, archaeology and geology. Okay, sekejap lagi, siapa lagi nak masuk? Sekejap kau nama, keeping. Okay. Next. Sambung Okay, for archaeology and geology, carbon 14 is used to study the age of ancient artifacts. Or in simple words we call as carbon dating. Okay, carbon dating. Nak tahu berapa tarikh usia satu benda yang kita jumpa tu. If you found an artifact, you jumpa pinggan dalam tanah. So we can use the carbon 14 to detect actually how old are the pinggan. Okay, how old are the tulang? Kalau jumpa tulang, how old are the bone? Okay, food technology, cobalt 60 is used to destroy the microorganism, that is food irradiation process. In paper industry, americium 241 is used as sensor to control the thickness of papers. Okay, kena panjang sikit Edison jawapan dia. Controls the thickness of paper. Dia bukan sensor saja, but it used to control the thickness of paper. Okay, electricity generation, uranium 231 is used to produce electricity by making a steam which spins a turbine to drive a generator and producing electricity. So uranium 235 ni dia akan keluarkan dia adalah kita panggil nuclear energy. Tapi so apa yang nuclear energy tu means, it will produce heat. Dia akan keluarkan haba yang panas. So the heat is used to make steam which spins a turbine to drive a generator, hence producing electricity. Okay, this is the answer. Okay. Okay, as usual, you have to do notes, congratulations, Tanya, Edison, siapkan nota. Very good. Okay, very good. Yang lain mesti ikutlah macam ni. Okay, very good. Congratulations, siapkan nota. Okay, another one. Kita ada 2 latihan. Okay. Tengok yang kedua. Second one. Ni kah? Tadi dah buka tu kan? Tengok ni. The second one. Okay, the second one. Informative practice 8.3. State the definition of isotopes. Isotopes are atoms of the same element that have the same number of protons but different number of neutrons. Okay, give 3 examples of isotopes. Carbon 14, sodium 24, cobalt 60. Tadi ada lagi americium 241. You pilihlah 3 saja. Okay, an atom has 10 protons and 10 neutrons and 10 electrons. What is the nuclear number of the atom? Okay, you have to remember nuclear number only protons and neutrons. 10 plus 10 will become 20. Okay, what are the uses of isotopes in the medical field? Kill cancer, treat thyroid cancer, treat tumor growth in the brain and more. Okay, so you kalau eloknya for this question number 4 ni, you sebut satu-satu. Carbon 14, what is the uses? Okay, sodium 24, what is the use? Cobalt 60, what is the use? Example, cobalt 60 to kill cancer cells like that. Okay, however, teacher terima jugalah. Tapi dalam peperiksaan, seeloknya ditulis lah. Okay, so thank you. Very good, Edison. For the other student, I hope you follow Edison buat latihan macam ni. Jangan tak buat. Jangan seorang saja. At least mujur ada wakil. Kalau tak ada wakil, satu kelas teacher hantar nama dekat pengetul. Tak siap kerja. Okay. Okay, kelas? Boleh? Boleh siapkan kerja after this? Rician, boleh ke? Nak cakap apa? Tak boleh. Okay, can we proceed with new topic? Boleh ke? Boleh. Okay, get ready. This is chapter 9. Chapter 9. Kita nak masuk chapter baru. Okay, kejap Make sure you have your textbook with you. So bila you ada textbook, lebih mudah untuk you refer. Okay, if you don't understand anything, you boleh refer. So lebih jelas. Okay. Ya. Kita tengah buka. Okay. 11 orang saja. Mana lagi yang lain? Kejap, teacher nak kejut juga yang lain ni. Sekejap. Dah nampak skrin kan? Kalau teacher start ni, tak ada yang masuk nanti. Kita dah masuk tajuk baru dah. 3 orang je online. Where are the others? Okay. Nampak skrin eh? Okay, we are going to learn today about chapter 9, Chemical in Industry. Okay. Can you see my screen? Dia cakap tau, teacher tak dengar, tak boleh tengok. Kevin, boleh nampak tak screen? Fefe, boleh nampak tak screen? Cakap sikit. Teacher tak boleh tengok chat. Saya nak masuk topik baru. Can you see the screen? Chemicals in Industry class. Can you see the screen? Edison?
Boleh.
Boleh eh? Okay. Okay, we'll start with 9.1, that is alloy. Okay, by the end of this lesson, students should be able to 9.1.2, define and give examples of alloys based on their composition of elements. Okay, you have to give what are the example of alloys and what is it made up of. Okay, dia dibuat daripada apa? You kena tahu. Okay. The second one, you have to carry out an experiment to compare alloys with its pure metals. Okay, and here we have 2 experiments. One of the experiment you can do at home. I want you to do videos on this experiment to get PBD, for your PBD. So siapa yang buat, siapa yang complete this experiment, teacher boleh bantu you bagi TP5 or TP6 lah based on your work. Okay. And the third one, you can justify the use of alloys in daily life. What are the uses of alloys in daily life? Are alloys important for us or not? Okay. Do we need to use alloys in our life? Okay. Alloy. Okay. An alloy is a mixture of several types of metals or a mixture of metal and non-metal by a certain percentage. Okay, make sure you write notes on this. Ni penting. Okay, you have to define alloy. Alloy is a mixture, campuran, several types of metals or a mixture of metal and non-metal by a certain percentage. Apa saja logam yang bukan dia saja, example as gold. Okay, gold 100% gold tu gold lah. Tapi kalau macam you pergi beli emas dekat kedai, dia dah jadi alloy. That's why the emas is 916. Maksudnya 916 dia bukan 100%. Dia bukan 100% datang daripada emas. Dia ada composition lain. That is alloy. Okay. So kalau you campur, katalah you ada besi and then you campur besi tu dengan aluminium. Dia bercampur 2 logam. One it is mixture. So dia dah dinamakan alloy. Kebanyakan metal dalam kita punya kehidupan sekarang adalah alloy. Jarang sangat. Very hard to find pure metals. Okay. Tapi kalau you pergi kedai, mungkin you beli emas 999 tu almost pure. Okay. Kalau you pergi beli silver, 999 punya silver yang betul-betul pure silver, mungkin pure. Tapi kebanyakan things, metals that you use in our daily life is an alloy. Okay. There are several types of alloys which are commonly used in daily life, such as steel. Steel, you know what is steel? Keluli. Okay. Pewter, bronze, brass and duralumin. Okay. Kita ada gangsa, kita ada loyang and also duralumin. Okay, and we'll go each this one kita akan bincang one by one. Okay. Okay, the first one is steel. Okay, these are the composition, properties and the uses of alloy. Okay, the first example of alloy is steel. Okay, steel is made up from 99% of carbon, 99% of iron and 1% of carbon. Okay, karbon ni adalah yang berada di karbon ni dia antara sifat dia antara metal to non metal. So ion 99% plus carbon, it becomes steel, akan jadi keluli. That's why you can see that the steel dia ada warna hitam sikit, gelap sikit. Okay, what are the properties of the steel? It is hard and strong. You have to remember this one. You kena ingat steel comes from iron plus carbon. Remember also the composition. The most in steel is iron. Kita tambah carbon sikit je, 1%. However, it has made the steel to become hard and strong. So what are the uses of steel? To construct construction materials for buildings, bridges, to make frame of vehicles and railway tracks. Kita punya kereta keluli. Dia ada rangka dia keluli. Okay, rangka dia adalah keluli. Jambatan, nak buat rumah, nak buat bangunan. Also, all these are made from steel. Okay, so tengok ni nak buat terowong, steel. Nak buat enjin dalam tu yang keras tu, bahagian yang keras tu steel. Ni railway roads ni. Landasan kereta api, railway roads also comes from steel. Okay, kita tengok this video. Watch this video, endless uses of stainless steel. Okay. So mana? Is it interesting? The uses of steel. There are so many uses of steel. Okay. Ya. Dia macam dengar dia nak masuk tadi. Ada ke yang nak masuk? Okay. Okay. Nak masuk. Okay. So far boleh follow?
Boleh.
Boleh okay, nampak kan seronok kan sebenarnya steel banyak saya gunaan steel dia. Lots of uses of steel. Okay, cantik, dia long lasting, kita tak perlu cuci selalu. It's very good. Okay, so kita sambung. Ya. Next. Okay, the second one is pewter. Okay, pewter comes from 96% of tin. Alah, seorang yang nak masuk sekejap Saya nak kena approve dulu. Apa nak masuk tadi pun dah add. Dia dah boleh masuk ke? Okay, pewter come from 96% of tin, 3% of copper and 1% of antimony. Okay, ni kalau you tengok color dia, the color, ni color of tin macam ni lah. Copper punya warna macam nak orange sikit, and antimony pun warna lebih kurang macam tin. Okay, so what are the dia punya ciri? Okay, what are the characteristic of pewter? Luster ni maksudnya dia berkilat. Okay, resistant to corrosion, dia sangat tahan karat, dia tak akan berkarat, dia tahan lama, long lasting. So what are the use for pewter? Usually pewter is used to make decorative items such as photo frames and then some coins. Okay, lepas tu cawan, gelas. And actually pewter ni agak mahal kalau you pergi beli dekat pasaran. Okay, sebab dia sangat cantik. Okay, biasanya dia sangat berkilat, ada luster. The luster effect means orang lagi suka sebab dia sangat berkilat, sangat cantik. Okay, and it very resistant to corrosion. You tak perlu nak jaga dia teruk-teruk sebab dia memang tak berkarat. Okay. Okay, this is some of the uses for pewter. Tengok, buat pinggan. Okay, buat periuk. Okay, buat tempat simpan lilin. Okay, ada satu video. Kita tengok how they make pewter tank cups. Pewter tank cups ni bekas yang untuk minum simpan bir tu kan, yang cantik. Kalau cerita orang putih, dia kalau cerita zaman-zaman Roman, zaman-zaman dia punya lama-lama dulu mesti ada benda ni. Okay.
A traditional drinking vessel typically used for beer. A tankard often has a hinged lid you raise and lower with a thumb lever. Dating back to 15th century England, they were initially made of wood, then silver or pewter. The tradition of handcrafting pewter tankards continues today. This manufacturer makes pewter tankards in many styles, one of which has the legend of the king's shilling engraved on it and a reproduction of a shilling coin from 1816 encased in the glass bottom. Every step is done by hand, beginning with a sheet of pewter that's just more than 1 millimeter thick. Using a punch press, they cut it into the shape required to form the tankard's body. Next, they place the pewter on a copper plate, which has on it, in raised lettering, the story of the king's shilling. They feed this in between two rollers, which press the lettering into the pewter. A soft metal, pewter is composed mostly of tin, along with smaller quantities of two other metals, antimony and copper. Next, a metalsmith takes over. He manually bends the pewter into the cylindrical shape of the tankard's body. He brushes on flux, a chemical which helps molten metal flow more easily. Then, with a soldering tool, he fuses the edges of the body with pure tin solder. Traditionally, both the pewter and solder contained lead, but today, both are lead-free. Next, the metalsmith slides the cylinder onto a steel form and hammers the solder seam flat, rendering it virtually invisible. Now, a specialized tradesman known as a pewter spinner slips the body onto a lathe. As the lathe rotates, he uses a series of tools to smooth the surface, trim excess off the top and bottom, and turn the top edge over to form a lip. Next, a buffer uses pumice and a cloth buffing wheel to remove imperfections and make the surface silky smooth. Meanwhile, in the casting department, they heat solid pewter to 240 degrees Celsius, then carefully pour the now molten metal into a rubber mold. Inside are several cavities for shillings and large rings. After about 30 seconds, the pewter solidifies and the parts can come out. To make the tankard's handle, the casters pour molten pewter into a steel mold, then tilt the mold in all directions to spread the rapidly setting metal all along the wall of the cavity. This makes the handle hollow and therefore lightweight. They grind the ends on an abrasive belt so the handle will fit flush against the tankard body. Another worker, meanwhile, assembles the tankard's glass base, a glass disc, a shilling, a ring, then a second glass disc. The ring acts as a spacer, creating enough of a gap between the glass discs to allow the coin to slide around. He applies waterproof glue around the perimeter to adhere everything together. Next, he places this shilling sandwich in a pewter base and adheres a second ring to hide the glue. Back to the metalsmith now. He dabs the tankard's body onto a pad impregnated with flux. He then solders together the body and base. Once the parts are attached, a final buffing with a soft felt wheel. Next, the metalsmith dips the handle ends in flux and solders them to the body. Avoid scorching the tankard's surface. This time, he uses a bismuth and tin solder, which requires a lower temperature to melt. The tankard is now fully constructed. They clean it in a dishwasher. Then they shine it up. First, the polisher does the inside, using a rough grit abrasive compound, producing a matte finish. Then he polishes the outside using a finer grit compound. This produces a contrasting mirror finish. In 18th and 19th century England, a volunteer for army or naval service accepted a shilling as a bonus upon signing up. However, volunteers were in short supply, so recruiters are said to have visited pubs and slipped shillings into the pewter tankards of inebriated men who, upon their last sip, discovered they'd been duped into serving. It may well be a myth, but it still makes a darn good story to share over a pint.
Okay, how was the video? Menarik tak? Sekejap kita tengok nak masuk tadi. Bunyi ting tapi masa teacher tengah present, teacher tak boleh nak admit. Okay. So, menarik tak? Macam mana? How do you find the videos? Is it interesting? Pewter tankard, and you can see how shiny is the pewter, how luster it is. Okay, so memang sangat cantik. Okay, so dekat Malaysia ni pun kita ada satu Royal Selangor kata silap. Memang dia ada keluarkan bahan-bahan pewter, okay, and it is sold in very mahal juga lah, exclusive price. Okay, can we continue? Boleh sambung? Baru 2 kan? Okay, next. Okay, the third one is bronze. Okay, bronze is made up from 88% of copper and 12% of tin. Okay, copper or other name is cuprum. Sama lah, cuprum, copper, cuprum. Okay, copper 88%, tin 12%. Okay, and the characteristic for bronze, it is hard, okay, resistant to corrosion, and it has attractive color. Okay, what are you used to make monuments, metal sculptures, coins, medals, and others. Gangsa lah, kita panggil gangsa. Okay, ingat gangsa, bronze. Okay, to make monuments, metal sculptures, coins, medals, and others. Okay, here are the uses. Okay, so ni lah warna bronze. The color of bronze, nampak dia warna macam nak orange sikit. Okay, these are the uses of bronze. Okay. Okay, next is brass. Brass atau kita panggil loyang dalam bahasa Melayu. It is made up of copper, 75% of copper, 25% of zinc. Okay, brass has strong, shiny surface, malleable, gold in color. Okay, brass is used to make keys, door knobs, musical instruments such as trumpet. Okay, here are the brass. Kalau tengok warna dia nak hampir sama with the bronze, tapi dia brass ni dia macam yellowish sikit. Bronze dia more to orange sikit. Okay. Okay, here are video.
Hi, and welcome to Metal Soup Markets, the convenience stores for metal. I'm Jason Jackson, Operations and Development Manager. At Metal Soup Markets, we carry a selection of red metals, a term that refers to copper, brass, and bronze. These three metals are similar because they all derive from copper, but they are actually quite different. Today, we'll discuss those differences. Let's start with copper. Along with having good strength and formability, copper is an excellent electrical and thermal conductor, second only to silver in electrical conductivity. It can be soldered, brazed, polished, and buffed to almost any desired texture and luster. Copper also has two other important attributes. It is corrosion resistant, and copper is found to kill more than 99.9% of bacteria within 2 hours of contact. Copper is most commonly used in applications such as wire, electrical motors, pots, and pans. Brass is a copper alloy that consists mainly of copper and the main alloying element, zinc. Brass can have a varying color, ranging from red to yellow, and have different properties depending on the amount of zinc or other elements that are added. Generally, if the zinc content ranges from 32% to 39%, the brass will have increased hot working abilities with limited cold working. If the brass contains over 39% zinc, it will have a higher strength but lower ductility. Brass is commonly used for decorative purposes due to its resemblance to gold. It is also used to make various musical instruments, mainly due to its high workability and density. Bronze is a copper alloy with the main element being tin and contains various other elements such as phosphorus, aluminum, manganese, and much more. Bronze can be identified by its dull gold color, but also has faint rings on its surface, which is a result of being centrifugal casted. Bronze is primarily for sculptures, metals, and in industrial applications such as bushings and bearings because of its low metal-on-metal friction. Bronze also has many nautical applications because of its excellent corrosion resistance. Hopefully this has given you a better idea of the differences between the main red metals, copper, brass, and bronze. Metal Soup Markets is the world's largest supplier of small quantity metals, carrying over 8,000 types, shapes, and grades of metal, including copper, brass, and bronze, cut to size. Visit one of our Metal Soup Markets locations.
Nampak tu iklan. Okay, iklan, advertisement. Okay, tapi nampak ada teknik dia bagi iklan and in the same time it give you education. Dia bagi satu pendidikan. You can differentiate between the copper, the bronze and the brass. The bronze and the brass. Okay, next. The last one is duralumin. Okay, duralumin pun you kena sangat-sangat faham, kena ingat. Okay, because duralumin contains from 95% of aluminium, 3% of copper, 1% of magnesium, and 1% of manganese. Okay, aluminium, copper, magnesium, and manganese. It is light, strong, and very resistant to corrosion. Okay, duralumin, it is very light. Berbanding dengan lain, dia adalah antara logam yang ringan. Okay, why? Because aluminium is also a light metal. Okay, so it is used to make frame for aircraft, aeroplanes, and others. Dia sangat ringan tapi sangat kuat. Okay. Okay, here are some of the functions of duralumin. Okay, kebanyakannya in aircraft lah, ada juga dalam pistol. Okay, and in gun, dalam pistol, penghasilan alat senjata. Okay. Okay, next, alloying. Generally, most pure metals are soft and can corrode easily. Okay, biasanya bahan-bahan logam ni dia lembut. Example yang paling mudah you tengok emas gold yang 999. Dia sangat lembut. Kalau you pakai emas 999 dia mudah patah, dia boleh tarik-tarik, dia lembut. Okay, sama juga macam 916. Dia masih lembut. Tapi kalau you beli yang 725 yang semakin ke bawah tu, dia agak keras. So dia lebih tahan lasak lah. Okay, biasanya pure metals, most of the pure metals are very soft. Selain dia lembut dan dia juga mudah can corrode easily, mudah untuk terhakis. Kalau you mandi ke apa ke dia mudah terhakis. Okay, kena sabun ke kena apa sikit dia mudah terhakis. Okay. Dan juga mudah berkarat lah. Okay, these properties are not suitable for producing most of the things around us. Jadi sifat macam ni, kebanyakan barang dekat rumah kita kena tak sesuai lah nak guna. Example kalau you guna iron nail kan, besi, paku besi biasa, dia akan cepat berkarat. So kalau you guna, you letak dekat rumah you paku-paku tengok dah berkarat, tak cantik. Okay, bila dia berkarat, dia tak cantik. Selain tak cantik, dia juga akan jadi lembik, lemah. Okay, mudah rosak. Okay. Therefore, the process of forming alloys or alloying is done to improve the properties of pure metals. Actually, alloys is better than pure metals because dia telah menambah, it improve the properties of pure metals. Okay, so the process to mix pure metals into alloy is named alloying. Okay, proses nak jadikan metal yang tulen itu kepada yang alloy kita panggil sebagai alloying. This process is called alloying, process of forming alloys. Okay. The atoms in a pure metal are arranged orderly in layers. Okay, if you can see from this figure 9.1, arrangement of atoms in a pure metal. Okay, in pure metal, atoms are arranged orderly in layers. So one layer state on one layer, state on one layer, another layer. So the layers of atom in pure metal can slide over each other easily when force is applied. So when we give force, example you have tadilah gold 100% pure gold, and then you use force, you ambil satu benda you ketuk. So the layers of atom and pure metal can slide over each other easily, sangat mudah bengkok. Okay, because of the arrangement. Because of the arrangement tu macam just atas. So bila kita tekan, dia boleh bergerak dengan mudah. Okay, it can slide over easily. Okay, so that shows that pure metals is not strong enough. Okay. So to make the pure metal become stronger, to improve the characteristic of a pure metals, we will do a process that is named alloying. Okay. So when one or more metal or non-metal elements are added into pure metals, the atoms from these elements make the layers of pure metals atom difficult to slide over each other. This is because 4-inch atom has different sizes. This makes alloys stronger and harder than pure metals. You see from this diagram, here are atoms of pure metals. Here example atom of 4-inch metals. So when we combine, okay, so the atom in 4-inch metal will akan isi, will fill in the atoms of pure metals. So when force is applied, the layers of atom in pure metal have difficulty to slide over each other because there are atom of 4-inch elements that sekat dia. Okay, that block the atoms of pure metals from moving. Okay, so atom of 4-inch elements will block the atom of pure metals from moving. This what makes alloy stronger. Okay, this makes alloy stronger. So you have to know how to draw this one. So kalau you lukis alloy, you kena make sure you lukis size yang berbeza. Dua size yang berbeza. Satu, the pure one sama size yang the pure one. A 4-inch element mesti beza size daripada the pure metals. Okay, this is what we call an alloy. Okay, several properties of alloys and pure metals can be investigated through experiments in the laboratory. Okay, so let us carry out experiment 9.1 and experiment 9.2. Okay, refer to your textbook page 186 until 187. One of these experiments can be carried out at home. Okay. Okay, this is the first experiment. Ini susah lah you nak buat dekat rumah. However, you can try kalau you ada hammer ke, tapi you kena modify sikit lah you punya experiment. Okay, this first experiment is to study the hardness of alloy compared to pure metals. Is alloy harder than pure metals? Our hypothesis, alloy is harder than pure metals. So what are the variables? Manipulated type of metal blocks, which we use. One is copper block, another one is bronze block. Okay, bronze is the alloy, copper is the pure. Corresponding diameter of the dent, constant diameter of steel ball, height of the wick, mass of the wick. Okay. So apparatus, steel ball, weight 1 kg, hanging, retort stand and clamps, ruler, metal rule. Okay, so procedure, first of all, we have to prepare like this. Okay, make sure you put ruler to measure that the height is same. Okay, when you repeat the experiment with bronze. Okay, we start with the copper and then we repeat with bronze. Okay, hang a 1 kilogram weight 50 centimeter above the copper block. Release the weight so that it falls onto the steel ball attached to the copper block. Observe and measure the diameter of the dent formed on the surface of the copper block using a ruler. Repeat step 2 to 4 twice. Okay, you repeat it twice on different surfaces. Okay, if the first one you buat kat depan, you check dia punya kedalaman, the height of the dent, the diameter of the dent. Okay, sebab dia macam ni you letak bola. Okay, letak satu bola kan, steel ball. And then bila kita lepaskan weight ni, dia akan hentam. Steel ball ni akan masuk dalam copper block. And then kita akan sukat kedalaman. What is the diameter of the dent? Berapa dalam dia masuk. Okay. And then you buat dekat dua tempat lah. So that you boleh tengok the purata, what are the average. Okay. And then you repeat the step with changing from copper block with bronze block. Okay. After that, put in the result. Okay. You buat 3 percubaan lah. Example, you buat 3 percubaan copper. First one, second one, third one. And then you campur 3-3, bahagi 3, you will get the average. And then do the conclusion. Is the hypothesis of this experiment accepted? What is the conclusion of this experiment? Okay, teacher akan tunjuk satu video eksperimen. This is one teacher buat. Ada seorang teacher yang buat dekat Makmal. Okay, watch this video closely.
Eksperimen mengkaji perbezaan kekerasan antara alloy dengan logam tulen. Pada kelas yang lalu, anda semua telah belajar topik 1.0 kimia industri. Dalam topik itu, anda telah diperkenalkan tentang beberapa ciri logam tulen dan alloy. Jadi, pada hari ini, kita akan menjalankan eksperimen untuk mengkaji perbezaan kekerasan antara alloy dan logam tulen. Tujuan eksperimen kita pada hari ini adalah untuk mengkaji perbezaan kekerasan antara alloy dengan logam tulen. Hipotesis bagi eksperimen ini adalah alloy lebih keras berbanding logam tulen. Para pelajar boleh mencuba menjawab soalan pemboleh ubah apabila melihat video eksperimen ini. Prosedur eksperimen. Susunan radas disediakan seperti dalam rajah. Pemberat 1 kilogram digantungkan setinggi 50 cm dari bongkah kuprum. pad dilepaskan supaya terhentak ke atas bola keluli yang dilekatkan pada bongkah kuprum. Diameter lekuk yang terbentuk pada permukaan bongkah kuprum diperhatikan dan diukur menggunakan pembaris. Langkah 2 hingga 4 diulangi sebanyak 2 kali lagi pada permukaan yang berlainan untuk mendapatkan diameter rata lekuk pada bongkah kuprum. Langkah 2 hingga 5 diulangi dengan menggantikan bongkah kuprum dengan bongkah gangsa. Keputusan eksperimen perlu diisi di dalam jadual.
Pada bahagian keputusan, so untuk yang berada di rumah, bila lihat gambar-gambar keputusan yang telah diberikan, so anda dihendaki membaca bacaan diameter lekuk yang terbentuk pada bongkah kuprum dan juga bongkah gangsa. Okey, yang berwarna merah. Bongkah gangsa. Itu untuk yang berada di rumah lah. Okey. So diameter lekuk ya. So kita kalau tengok diameter lekuk yang terbentuk tadi. Okey, untuk bacaan katakanlah kamu dapat tu 0.3. Okey, yang kedua katalah bacaannya 0.25. Ini saya bagi contoh, jangan tiru contoh saya. Sila baca bacaan yang ini ini contoh saja. Okey, yang ketiga kamu dapat 0.3 semula. Okey, bila menulis pada dasar yang ni tiga berapa so sambungkan semua. So ni ada di 0.3 kosong dan di bawah 0.3 kosong. Okey, masih sama. Kita boleh juga untuk awaknya yang sama ya. So gangsa dan kita lekuk dia mesti lagi kecil berbanding so untuk yang PPR tu kita tengoklah, kita rujuk bacaan gambar pada lekuk ini. Okey, next kamu sedang diraba kurata. Okey, so macam mana nak kira kurata? Ambil bacaan ini, tulis ke ni 0.30 tambah 0.25 tambah 0.30 bahagi 3. Saya tulis jawapan masing-masing. Sama juga kalau ada kata kita dua di pembunuhan, jawapan kamu mesti ada 2 titik pembunuhan. Okey, perlu tak tulis ni? Perlu ke tak perlu? Tak perlu. Kenapa tak perlu tulis ni? Ya, dekat jadual terhadap yes.
Gambar yang akan dipaparkan adalah bacaan bagi diameter lekuk pada bongkah kuprum. Isikan bacaan 1, 2 dan 3 pada jadual.
Okay.
Audio.
Kita stop Okay kelas. Nampak tak eksperimen tu tadi? So kita lagi 2 minit. Okay, nampak eksperimen tadi? Okay, that is the first experiment 9.1. Okay, apa yang teacher akan buat, after this I'll give you that video. Teacher akan hantar video ni dalam group Telegram. Okay, teacher nak you buat report on that video, on that experiment based on the result yang diberi dalam video tu. Okay, you kena buat report dia. You kena jawab lah soalan on page 186. Okay, kita ada latihan dalam buku sains proses skill. Tengok page 86. Okay, later on teacher bagi dia punya muka surat. Okay, teacher nak you buat report eksperimen tersebut. Okay, dan buat nota ringkas on the topic yang kita dah belajar sikit. That is the example for alloys. You kena buat latihan nota sehingga example of alloys. And then eksperimen 9.1. Okay, in the next class kita akan bincang untuk eksperimen 9.2 and kita sambung sikit lah untuk the next subtopic. Okay, eksperimen 9.2 you boleh buat dekat rumah. Okay, so if you have any question tolong tulis dekat komen sebelum kita tamatkan kelas ni. You have any question so far? Okay, yang lain buatlah juga kerja. Takkanlah Edison seorang, yang lain. Okay, dulu Wu Jeremy, Kim Min Jun, Yeo Seng Wei, Tang Pui Fu, Tan Kezin, Jiu She, Chiu, Bion, Jonah, Li Ching, Li Qian, Kezin, buat ya. Okay, buat latihan, buat nota. Okay, eksperimen 9.1. Later on teacher akan hantar video dalam group. You tengok dan you buat report. Okay, so by that kita tamatkan kelas untuk hari ini. If you have any question boleh tanya dekat dalam Telegram. Okay, thank you class for attending my class. Bye-bye.